Advanced Oil and Gas Management. My name is Dr. Ima, and I'm excited to be with you again today. I believe I can be well heard, and my screen is also visible. I hope that's what it is. Um, if that is it, then we can have a very smooth ride. I believe you can see my screen clearly, and you can also hear me clearly. All right. In our previous class, we had an overview of the advanced oil and gas management, with talking about or starting from the very onset or the very beginning, the which is like the foundation of this program, talking about how um, oil and gas is formed, the formation or origin, and then the processes that they go through and all of it. All right, without taking much of our time, uh, some areas that we needed to lay some emphasis on, we'll be discussing today, and I believe we're going to have a fantastic time together. All right, and that's the area of oil and gas processes, and we had actually laid a foundation on this in our previous class, and we said that the oil and gas processing involves involves what now? Refining of crude into its usable product. But today's class will be looking more on the um, gas processing and LNG. Okay, and hopefully in our last class will be, or in our next class rather, we'll be having more insight on these other areas. All right, talks about the oil and gas process. Um, if you recall, we said the oil and gas process involves what now? Refining crude into its usable products. I want to talk about its usable separate. We also look at what now? Separating natural gas into its components too. All right. Remember, we had laid the foundation that what now? The crude itself is laden with a whole lot of impurities, a whole lot of impurity when it's coming from the earth crust, and also has or comprises several fractions which can only be separated when they are made to go through a process of what now? Refining. Refining is the process where by the crude is subjected to what now? Temperature and to heat, increased temperature through the distillation column, and then what happens is as it boils, as the temperature of the crude is of the oil is increased, its different fractions begin to work now. They begin to distill out at their boiling point, okay, depending on their molecular weight. So two factors that's responsible for what now? This separation is what now? The molecular weight differences and the difference in their boiling point. All right. So in doing this, we'll also get the lighter products first before we get the heavier products. All right. And we have different, we said earlier that was now the advanced technology in this stage includes what? Advanced refining processes, catalyst technology, we will make use of catalyst in either breaking down, especially when we are either breaking down heavier fractions to lighter fractions because of their higher demand, for instance. And such a process, we described it as what? Cracking. It can be catalytic cracking. All right. So we use that also. Even in reforming, which is the reverse of what I just said, we also make use of what now? Catalytic. There's a catalytic reforming and all that. So having this in mind, is also important that we understand that what now the process optimization is very critical in improving the efficiency and reducing environmental impact. So it's very important that we optimize the processes, ensure that it's done uh, as much as possible. The processes are carried out in such a way that it does not pose much threat to the environment. to the life around such area and the ecosystem also. So we look at gas processing and LNG, that's the liquefied natural gas. That's our core area of concentration for today, for this class, for today's class. I said that gas processing involves what now? The treatment of natural gas to remove impurities and separate valuable components. Now, when we subject natural gas to some form of treatment, we can take off the impurities and separate it into its natural components. The liquefaction of gas is because we want to try to be able to work now. For us to be able to contain the gases, understand the characteristics of gas molecules of gases, that they are very loose, they are loosely bound, the van der Waals forces or the force of cohesion among these molecules are very minute, so it makes it easy for them to move randomly. And it's so as such, they are not easy to be, or it's not easy to contain them, to handle them, to control them, to make use of them. All right, in that form. So they need to be made in a liquid form so they can easily be contained, they can easily be utilized, transported, or stored. All right, and in doing that, one of the things is to, according to the Boyle's law, you can bring down the temperature, reduce the temperature, increase the pressure, reduce the volume. All right. And when that is done, it compresses petroleum gas, which is popularly known as your cooking gas. That comprises butane and propane. But the natural gas is mainly of comprises of methane. All right. And we said that this uh, as I said earlier, it includes what now the cooling and liquefaction of what natural gas for easier transportation and storage. So advanced technologies in this area include cryogenic processes, advanced compression and liquefaction processes. All right, or techniques. These are is the liquefaction techniques I just explained earlier. So first of all, when we talk about the gas processing, we first have to understand what natural gas comprises of. All right, and rightly said, natural gas is mainly constituent or comprised or what now? Methane, which is about the lightest product from crude oil. All right. And the composition of natural gas is what? Methane, and then some other hydrocarbon impurities like CO2, um, acidic uh, gases like CO2, H2S, and then water vapor. Now, these are majorly the constituents of what we get from natural gas that is not yet refined. So, the importance as a clean and versatile energy source cannot be overemphasized. Um, this is because as natural gas, if you understand the combustion process of gases or of hydrocarbons, basically, when hydrocarbons are combusted, they produce, depending on the level of combustion, all right? So for complete combustion, you just have CO2 and what now? Water. That's H2O and CO2, which is not really hazard, it's not hazardous to the environment, basically. But when there's incomplete combustion, which can be especially as a result of the combustion of heavier compounds with less sufficient oxygen, heavier hydrocarbons, for instance, when they combust, you have incomplete combustion in such a case. And what you have is going to be what now? H2O and CO2 plus CO. CO, that's carbon monoxide or carbon 2 oxide, which is poisonous, hazardous to the environment and also to live to man or living things. Okay, basically. All right. The carbon monoxide, for instance, if they combine with the hemoglobin, they form what carboxyhemoglobin, which is dangerous to health and can result in death. Okay, and then we have the so as a result of this, it is very important that natural gas is made to go through a process of treatment to to expunge, to extract, or to remove these impurities that are constituent in it. All right. Now, however, natural gas is a cleaner form of um, of um, of energy because it's likely to it undergoes complete combustion. Hence, there is less pollution when you make use of natural gas as a source of fuel, as your fuel source. You understand? For our engines, for our systems, for other processes that we want to use. Imagine cars that run on gases, for instance. You discover that they produce less sooty flame. They don't even produce sooty flame, sooty soot from their exhaust. You understand? It's cleaner, it's purer, it's much better than other sources. All right. So it's very important that we understand that. And then the gas processing facilities. We look at when we talk about the gas processing facilities, we have the um, gas treatment plants, where these processes of sweetening, of dehydration, of um, extraction of all forms of impurities. Sweetening is the removal of the sulfur or acidic constituents like CO2 and H2S. We'll be looking at that shortly. And also the part of where water vapor is removed. So, but this is done using what the gas processing plant or treatment plant. And the purpose, like I said, the purpose is to what? Remove impurities and extract the valuable components from the constituents, all right? And the common components in the processing facility, you have the inlet separation, you have the compression aspect, compression where the gas is compressed, the hydration aspect where the water is water vapor is taken off. We have the sweetening section where the acidic gases are extracted from it, or acidic components constituent like H2S and CO2, and then we have the fractionation also, where other heavier components are also extracted based on the boiling point. All right. And in the inlet separation, you have initial separation of the oil from water and impurities from the raw natural gas because the natural gas is laden with some oils, it's laden with some water and other impurities. So in the inlet separation, the oil, all these parts are extracted. And then the equipment that are used for this kind of operation are our separators. In the separators, basically in a typical, maybe in our next class, we'll see some of the pictures better. You see different types of separators in the processing plant, different for different stages. You have the low pressure separator, you have the test separator, low pressure separator, high pressure separator, and the extra high pressure separator. Okay, they are labeled as test separator, LP separator, um, HP separator, SHP separator. So you have them like that. Then you have the scrubbers also and the knockout drums. Like the knockout drums are the last, are usually the last component before you get to the flare line or the extraction line for the gas. Okay, they are made to pass through the knockout drum where some of these, even for the liquefied, sorry, for the oils too, it's still the same process. Okay, they are made to go through the knockout drum where the last and which most times the last phase of the separation. There are also like separators, but what happens there is that the constituents are extracted, the extra and the oils, the vapor, and the rest of them are taken off and recycled back in, or are brought back into, channeled back into the separator, okay, for further separation or collection. All right. So, what's the purpose of compression, or the importance of compression in gas processing? Like I earlier said, it's for the purpose of being able to work now, handle or store or transport them. So compression is a process that is used to help to liquefy this gas, and that is done by increasing the pressure, reducing the volume, reducing the temperature also. Okay. And we'll look at the types of compressors that we have. We have two major types: the centrifugal and the reciprocating compressor. All right, the centrifugal compressor, they work like a centrifuge. The concept of, or the principle of the centrifuge. Okay, that's the principle it's used in compressing. All right, and then we have the purpose of what now? Compression. What is the purpose of compression? Is to increase what now? The pressure for transportation and for what processing of the products. All right. And then when we talk about hydration, we are referring to what now? The removal of water vapor from natural gas. And the methods that are used for hydration are basically the absorption, that's the use of desiccants, where you use desiccants to absorb the water. So the gas is made to pass through a channel or chamber with desiccants. They can't absorb the gases, but they will absorb the water vapor in the gases. Or we use refrigeration. Refrigeration is the act of what now? Reducing the temperature. And by the time you try to reduce the temperature, it will separate by um, the principle of their density differences. Okay, so it's easy to separate them by density difference. Certainly, the water vapor or water is more dense than or is denser than the gas, the liquefied form of the gas. So the refrigeration process works based on the principle of what now? Temperature reduction. All right. And the importance for preventing hydrate formation in pipelines, it cannot be overemphasized. Prevention of hydrate formation in pipelines cannot be. Hydrate formation is is something that can be very hazardous for for the transportation of products on the pipeline. Why? Because they eventually form what now? Um, blockages or form some kind of deposits too. And as a result, it becomes difficult or more difficult for such line to transport the volume or the flow rate as it's supposed to, at the flow rate of pressure that is supposed to transport the products. And what happens in such a case is that there is now a drop in pressure, and also some in some cases you have high level of impurity um, in such products. So how do we prevent or reduce the hydrate formation in the gases? Is by carrying out what now? Proper separation at the processing station to avoid to reduce the level of hydrate that is being formed, and also ensuring that what now? The pressure and temperature of which the fluid is flowing down the line is maintained at operational level as designed, that would avoid hydrate formation. These processes can be simulated, and softwares like ICs are also used in simulating this to be able to give us the best temperatures at which this operation can be conducted, the pressure also, and the other variables that are necessary for this to be done without resulting in what now? Hydrate formation. All right. Um, so from there we talk about now the stream sweetening process. Like I earlier mentioned, sweetening is the act of what now? Removing, or the process of removing acidic gases, primarily hydrogen sulfide gas, from the from the fluid. All right. Which acidic gases can be very poisonous and also very hazardous to the components of the refinery, the equipment itself. It can lead to rapid corrosion of the steel components of this facility, which can bring about a quick degradation of the facility, and that could also result in a quantum loss over time. All right. It can also be very poisonous to health. It's very poisonous to health. It's um, very hazardous to the environment. Okay, so the process of sweetening, one of it is amine treating, making use of the um, amino compounds to carry out the treatment. Okay, and we have the other one of scavengers. The scavenging process is also part of it, and the membrane separation, using of membrane as a separation system for this purpose. All right. So the significance of safety cannot go, and the equipment cannot be emphasized. The reason these processes must be carefully done, and the products, the um, gases must be stripped of these hazardous constituents, especially the hydrogen sulfide. All right. So it will help to protect the environment, environmental protection, because the compounds and the sulfuric constituent is very, like as earlier mentioned, is very poisonous, it's very hazardous to the environment, and it also dangerous to the equipment. It can affect it can lead to quick corrosion of the equipment too. Okay, and as well as um, the safety part too for health. It can be harmful to respiratory system, carcinogenic, and also causes respiratory defects in humans also, and can also cause some burnings too, and skin reactions also, and a whole lot of negative impacts that it has. So fractionation is the separation, like earlier said, is separation of what now the natural gas into its individual components. And we have the cryogenic process for liquefaction or liquefied petroleum gas extraction. And then we have the importance of producing market stable products. It's very important that we carry out this liquefaction, this separation of the constituent of in terms of the gas into its various constituents, all right, through the cryogenic process, all right, and it's mostly used for liquefied petroleum gas, which is comprised majorly of butane and propane, all right. We'll throw more light on this in our subsequent lab, and then the importance of producing marketable products. Like we had earlier said, if your product is laden with sulfur or some of these um, hazardous constituents, the product will have less value in the market, or such product, whether gas or even the oil, will have less value in the market because of the cost intensive nature of it being processed, what it will cost to process it again and purify it, okay, or sweeten it. So it is usually something that brings about low uh, low market value for such products. All right. So very quickly, also look at the storage and transportation of liquefied natural gases. And when we talk about the storage and transportation, we have to look at the types of storage tanks. Yeah, basically, you have spherical kind of storages, and the like I earlier said before, the kind of storage used for gases are not the same for oils or the liquids either. Okay, and that's because of the nature or the composition of this product. Okay, so as to ensure that their state, their liquefied state is maintained or sustained. It's very important that they are kept in specially designed kind of tanks, which are mostly spherical in shape. Okay. Now, we've talked about the global market, and we'll look at the challenges and the future development challenges of the in the liquefied natural gas industry. The volatility of the market is one of the major challenge because the market is very volatile. Um, the prices fluctuate randomly. For those of you who are very conversant with some of your or who make use of cooking gas, for instance, a whole lot, you will attest to the fact that in the last few months, you've seen a, a crazy trend in the increment of these gases. So it's something that has a global effect too. Okay. And then the geopolitical issues involved in this industry cannot be overemphasized. Right. That is in terms of the sales, in terms of the transportation, in terms of their location, the utility, and all that. The the the, the trade policies that are also involved too, from one country to another. Right. Um, a lot of trends now have emerging or already emerging in the processing of gas to make it an liquefaction process too. To kind of make it safer and easier, you know. So more designs have been made, more uh, complex process or less risky processes are being invented or are being looked into or researched to make it much easier for this to be done. And the role of LNG in the transition to a low carbon energy future cannot be overemphasized. Like I said earlier, LNG presents or profiles a cleaner source of fuel, for the oil and gas industry. Why? Because we can have this combustion and these processes done without pollution or with little or no environmental pollution, especially when the gases have been stripped of their basic impurities, So because these liquefied petroleum gas and liquefied natural gas are lighter fractions of hydrocarbons. So when they undergo combustion, it is easier for them to combust completely, to experience a complete combustion process. So it means that cleaner sources are produced as end products of their combustion process, which is what water vapor, H2, and what CO2, carbon dioxide or carbon dioxide, which is not hazardous to the environment. All right. So these are areas that are being looked into to improve to improve the impact on the environment and to create a safer, safer energy source, a cleaner energy source that should be very safe for the ecosystem also. So we'll hold it here until our next class. And I believe we have been able to learn one or two things about these processes. In our next class, we'll be looking at the unconventional sources of oil and gas and also the oil or refinery processes. Thank you and God bless you. From me, it is goodbye for now. Thank you.